Imagine a bustling city street, alive with the rhythm of daily life. Suddenly the ground groans. The asphalt cracks, spiderweb tendrils spreading outward with alarming speed. Then, with a terrifying roar, the earth collapses in on itself, swallowing cars, buildings and people in one devastating gulp. This is the terrifying reality of sinkholes, a stark reminder of the raw, untamed power that lies beneath our feet. These geological marvels, often appearing with little to no warning, serve as a dramatic reminder of the Earth's constant state of change. While they can occur anywhere, sinkholes are most common in areas where the bedrock is composed of soluble rock, such as limestone, gypsum or salt. These rocks dissolve over time due to the slightly acidic nature of rainwater, creating underground voids that can collapse without warning. These events, as sudden and unpredictable as they may seem, are the result of a fascinating interplay of geological processes, both natural and human-influenced. Understanding these processes is the first step in comprehending the awesome power of sinkholes. Sinkholes, in their simplest form, are depressions or holes in the Earth's surface that form when underground cavities collapse. These cavities develop over long periods, often centuries, as water seeps through the soil, slowly dissolving the bedrock below. This process, known as karstification, is particularly prevalent in areas with karst topography, characterized by soluble bedrock like limestone. The formation of a sinkhole is a gradual process, often beginning with subtle signs like small depressions in the ground or the wilting of vegetation. As the cavity beneath the surface grows larger, the overlying soil and rock become increasingly unstable, eventually collapsing under their own weight. While natural processes are the primary drivers of sinkhole formation, human activities can significantly accelerate the process. Overpumping of groundwater, for example, can lower the water table, weakening the support structure of the overlying ground and increasing the risk of collapse. Similarly, leaking underground pipes and heavy construction can alter drainage patterns and increase the rate of dissolution, ultimately contributing to sinkhole development. Sinkholes are broadly classified into three types: dissolution, cover subsidence, and cover collapse. Each type forms through a distinct process, resulting in unique characteristics and varying degrees of hazard. Dissolution sinkholes, the most common type, form gradually over time as the bedrock dissolves and the overlying soil slowly settles into the developing cavity. These sinkholes are often characterized by shallow, bowl-shaped depressions and pose relatively low risks compared to their counterparts. Cover subsidence sinkholes develop when the overlying soil is sandy and permeable. As the bedrock dissolves, the sand gradually settles into the cavity, creating a gradual depression at the surface. These sinkholes, while potentially larger than dissolution sinkholes, typically develop over extended periods, allowing time for detection and mitigation. Cover collapse sinkholes, on the other hand, are the most dramatic and hazardous type. They occur suddenly when the overlying soil, often composed of clay or other impermeable materials, forms a bridge over a large cavity. The bridge eventually collapses under its own weight, resulting in a sudden and catastrophic collapse of the ground surface. History is replete with examples of sinkhole disasters, each a stark reminder of the destructive power of these geological phenomena. The 2010 Guatemala City sinkhole, a gaping chasm that swallowed a three-story building, stands as a chilling testament to the sudden and catastrophic nature of cover collapse sinkholes. Triggered by a combination of heavy rainfall from Tropical Storm Agatha and a leaking sewage system, the sinkhole, measuring 66 feet wide and 300 feet deep, claimed one life and left a scar on the city's landscape. In 1981, the tranquil town of Winter Park, Florida, experienced the wrath of a sinkhole that would become a landmark case study in urban sinkhole formation. What began as a small depression in a parking lot quickly escalated into a massive sinkhole, swallowing a car dealership, a swimming pool, and several homes. The Winter Park sinkhole, ultimately measuring 350 feet wide and 75 feet deep, highlighted the role of human activities, particularly groundwater pumping, in accelerating sinkhole development. Beyond isolated incidents, certain regions around the world are particularly susceptible to sinkhole formation. China's Tiankongs, for example, are a breathtaking yet daunting spectacle of karst topography. These massive sinkholes, some exceeding 2,000 feet in diameter and depth, have formed over millennia, carving out a surreal landscape of towering cliffs and verdant valleys.